Well, hi everyone, and welcome to our monthly SLCan webinar series. Today, we're very pleased to have Rick Johnson here with us to talk about sustainable designs for laboratory service fixtures and emergency shower systems. I would, as usual, I would just ask that all attendees, if you have questions throughout the presentation, if you can simply type them in the questions box, and at the end of Rick's presentation, we will go through them one by one and hopefully get everything answered that everyone's inquiring about. As I said, we're very pleased to have Rick Johnson of Brown Lab here today. Rick has over 25 years in research and development, design, and product management in laboratory furniture, fixtures, and fume hoods. He's been the past chairman of CIFA and has been a guest speaker at the Tradeline, Arab Lab, PitCon, and USGBC Green Build conferences. We're very pleased to have him here today, and without further ado, I'll turn it over to you, Rick, and we'll go from there. Thank you.
Well, good afternoon. Thanks for joining this webinar. I'm going to cover a subject here that is very important to me personally and professionally. We're going to cover environmental health and safety considerations for laboratory service fixtures, emergency shower, and eye washes. Again, getting back, I'm the North American Key Account Manager. You can see on the first screen here. You've got my contact information and my number. If you need to get a hold of me, please do. For the agenda today, we're going to cover CIFA, Scientific Equipment and Furniture Association, the CIFA 7 standards. Another subject we're going to cover is environmental friendly materials and finishes, reducing water requirements, media types and special applications for service fixtures, emergency shower and eye wash requirements and standards, and any other considerations, covering both laboratory service fixtures and emergency showers. Laboratory service fixtures come in a number of different varieties, depending on what the media type is. To set the standards, we have a CIFA recommended practice. CIFA 7 covers laboratory and hospital fixtures. CIFA 7 was based on performance standards based on the existing ASTM standards for material types of copper, brass, coatings, adhesions, construction, special considerations for burning gas, vacuum breakers, backflow preventers, etc. When you look down through CIFA 7, there's a lot of different sections incorporated into the recommended practice. I'm just going to cover a few of them this afternoon. 4.0 defines the industry product types for laboratory fixtures. 5.1 is the materials used in laboratory fixtures. 5.2 defines the finish types and testing methods, the fume hood test, chemical test, adhesion test, and some of the other testing that's conducted on laboratory fixtures. 5.2.3 covers the corrosion resistance, and it's based on the 49 chemicals that CIFA has established. There should be no more than 4 level 3 conditions, which we consider failures. Some of the other considerations, 7.3, would be field installation, recommended practices for cleaning, testing, threading, and connections for the service piping. 7.5 covers markings, be it CSA or UL, and color coding as it's defined by CIFA 7 and the EN DIN standards. When you look at the coatings, especially on handles, there's going to be 3 different zones. The handle is going to be colored for the media fixture and the media type. Then you've got a ring for an off and on position. Then you're going to have the media indicator button in the center. 8.1 is general requirements in a laboratory environment, working temperatures, be it high or low, and that goes anywhere between 45 degrees and 145 degrees Fahrenheit. We're also going to have a strength test, life test, shock test, vandal resistance, etc. 8.4.1 is the strength test which covers a variety of different testing methods, be it a burst test, bending loads, handle security, etc. 9.4 are valve and pressure regulators in regards to high purity and ultra high purity gases. That covers both the construction and the performance requirements. Finally, 17.0 covers emergency eye washes and showers, both the construction and the performance requirements. Environmental friendly materials. A lot of this is based on existing ASTM standards as it requires, and the material types for copper alloys, red brass, seamless copper piping, aluminum alloys, injection, and extrusion materials as defined by ASTM standards, both for specifications and performance requirements. I'm getting a lot of questions from architects and the lab planning community about lead-free fixtures, which is really becoming a predominant subject in subject conversations within the last couple of years. And this has been driven by the Safe Drinking Water Act, requires water products sold or installed for public use, as well as plumbing and facilities, to meet the weighted average of not more than 0.25% lead. Third-party testing and certification will be required in many different jurisdictions because they will vary. And a lot of people don't realize that there's no such thing as a lead-free fixture. There's always going to be a certain amount of lead within the lead brass itself. You need that during the milling process and the threading process. It acts as a lubricant. So there should be a minimum of 0.25% lead within the fixture itself. Lead-free fixtures are defined by NSF, ANSI standards, and 3.72 certification as required by the NSF mark. There should be on all the products to avoid confusion in the marketplace. From a CFA standpoint of view, it is our position that laboratory fittings are not designed, manufactured, sold, and installed for the purpose of delivering water for human ingestion. But this is the CFA standards, but I'm seeing a lot of lead-free fixture requirements showing up in project specifications. Environmental friendly finishes. You know, this is another subject, conversations about chrome. Chrome is a typical finish for any laboratory fixtures in North America, but not so in Europe. Europe has really abandoned chrome plating many years ago. Chrome has some nice attributes. It's reasonably abrasion resistant and inexpensive, but is known as a carcinogen that requires protective gear, uses lots of water, and you've got hazardous waste disposal you have to consider. It is also a chemical, it's on the chemical list of California Proposition 65 for reporting chrome plating. It is listed as chrome 6 in the Living Building Challenge materials. It is on the red list of not usage. Almost all manufacturers are now applying either urethane or polyester powder coats. Powder coat finishes perform better, totally CFA compliant, without the health of the water issues, and are readily available for most and all manufacturers. This is a recent development. Several college universities of customers have eliminated plated chrome from their LEED compliant campus-wide standards. There are two options available, either plating with chrome O, which is a metallic chrome, or powder coating that looks like chrome. Reducing water requirements. This is being driven by the USBGBC. It's LEED requirement 3. It follows under WE1, required minimum indoor plumbing fixture and fitting efficiencies. The requirement, reduce portable water use in indoor plumbing fixtures and fittings to a level equal or below the LEED 2009 standards for existing buildings. Fixtures and fittings, including those in this credit, are water closets, shower heads, faucets, which include laboratory faucets, faucet replacement, aerators, and metering faucets. So one of the things you might want to consider is specify low flow fixtures and faucets, flow restrictors, hands-free fixtures, and automatic shutoff valves, readily available on the market. Also, within the LEED recommendations, do not use aspirators on goosenecks for vacuum purposes. Each aspirator requires water rushing through at a close to 2 gallons per minute to produce vacuum. If used 2 hours a day, the aspirator will waste 50,000 gallons of water a year. When you look at the categories, when it defines the guidelines for laboratory fixtures, you have to break it down by media. Under water categories, you have hot and cold potable water, non-potable water, and coolant water, special waters, distilled water, and deionized water, which are all different type of laboratory fixtures. Gases categories are non-burning gases, 2O gases, which would be vacuum, 4O gases, which would be oxygen and the related gases. Then on burning gases, you have burning gases as defined by CGA, AGA, and NSF. As far as gases are concerned, you also have pure gases, 5O gases, and 6O gases, which are ultra high purity gases or instrument grade gases. Some of the safety and performance concerns for special applications, special water fixtures. You have to understand what the application requirements are. According to the DIN standards, the valve must be built in accordance to the DIN standard. So some of the special considerations is you have a 1/2-inch union nut plastic nozzle, which is a requirement to the DIN standards. Also has to comply with ISO standards. No lubricant against the media. All wetted parts in the plastic, be it PE, PTFE, or PP, that do not contaminate the water being used, that's critical. Safety and performance concerns for special applications for burning gas. Again, understand the application and understand the requirements. Fittings, laboratory fittings for non-burning gases, which would be typical 2.0, would be vacuum. Fittings for non-burning gases, which is 4.0, would include oxygen and gases with less purity than 99.99, which would include instrument-grade gases, zero air, synthetic air, nitric oxide. Then you get into ultra-pure, which is 5O and 6O, applicable for inactive gases with purity up to 99.9999%. All these fixtures must be assembled in a clean room environment. They also must be ultrasonically cleaned on all wetted components. Once they're tested, they have to be sealed. Metal diaphragms type pressure regulators for good pressure control and reliable services. When you go from 5O to 6O, the regulators are going to differ as far as construction. Emergency shower and eye washes. What is an eye wash? Eye wash is a handheld operator that must be operated with one hand. Must have a trigger lock and a backflow preventer. We also have paddle operated eye washes. Must be operated with one hand. One of the requirements is that you must flush your eyes for a duration of 10 minutes. Must be in compliance with the international standards, which is the European EN standards and the US ANSI standards. Emergency shower and eye washes. All emergency eye washes and showers and equipment installed in a laboratory facility shall comply with the ANSI Z standards. Follows under emergency eye washes and shower equipment. What is emergency shower? Emergency shower is critical and essential installations for employees that are working with any type of chemicals, a risk to exposure as far as boiling water or steam or heat, as well as a large amount of dust. A properly placed emergency shower can make a big difference when chips are down. Rules as far as design are concerned, if there's going to be any type of potential accident, you must locate an emergency shower or an eye wash within 10 seconds of the accident. It helps stop accidents when it happens. Secondly, it's a quick rinse in many cases to help reduce the accident consequences. Emergency showers are designed for body, face, and eyes. This falls under predominantly construction and performance requirement. When you look at the ANSI standards and the EN standards, as far as the construction and the performance, it includes the spray pattern, the shower head, the markings, the function of the valve, and the free space below the shower. As far as the value of emergency showers, this is a requirement. The valve must be opened in 1 second. Force applied to the activation not to exceed 10 kilograms. The valve itself must be opened in one movement. The valve must open by rotating or moving the valve actuator by 90 degrees. Valve shall not close automatically once it's opened, and the valve actuator must be placed it's 7 feet below the finished floor. Again, the spray pattern, water shall be distributed correctly. At a distance that would be 7 feet below the shower head, 90% of the water must be limited to a circle radius of 40 millimeters. Constant flow rate shall be 60 minutes per minute, 60 liters per minute. Again, you have the shower head's lower edge must be located from the finished floor. Signs and symbols. This is a critical indicator when you place a shower head, where you place an emergency eye wash within the facility itself. Testing equipment. Testing equipment is designed to carry out checks in accordance with requirements of the EN standard and ANSI standards. Testing devices can be used for the following. Should be used for volume flow measurements, visual check of spray patterns, visual check of the water quality, and under the ANSI and the EN standards, all eye washes and showers must be at least tested once a month. I was recently at MIT, and the city of Cambridge, Massachusetts, has just instituted a requirement on all new facilities that they must be tested once a week, which is a pretty severe requirement as far as the H&S personnel and facilities. Thermostatic mixing valves for body showers. It avoids hypothermia. It also has a safety check on it. If the hot water shuts off, the cold water is always going to continue to flow. But if the cold water shuts off with this valve, the hot water will automatically shut off. It's got a built-in thermostat that you can set it anywhere between 70 degrees Fahrenheit to 90 degrees Fahrenheit, depending on what the requirements are. They also have an anti-scalding device in it, which gets back to the valve itself. Also, thermostatic mixing valves for eye washes. Again, same type of requirements as far as anti-scalding and setting the temperatures. It's got a built-in thermostat. In summary, you must know the industry standards, the recommended practices, and either federal or local regulations. Choose the right product for the right application, and consult with your EH&S and facilities department on local jurisdictions. And they will vary from one geographic area to the other. So, going to conclude, you have my contact information there if you need to get a hold of me. So I'm going to take any questions.
Thanks, Rick. It's Kevin Humanick here. Can you hear me all right?
Yes, I can hear you.
Okay. While we're waiting for Martin to chime back in, I have a few questions.
Sure.
I'm here now. Go ahead.
Okay. Hi, Martin. Yeah, why does chrome finishes require more water and energy to fabricate? Is it specific to the fabrication process?
Yes, it is.
Okay,
yes, it is. It's all part of the fabrication process. Yeah.
And what is is there something in the nature of chrome finishes that's carcinogenic during manufacture, not during use?
Well, it's basically when you look at, the standard is considered a carcinogen, and that's the natural byproduct of chrome.
Right.
And when you're applying it, I don't know if you've ever been in a factory that applies chrome, be it a bumper or a service fixture, but you have to take into consideration special application environments. You got to wear protective gear. You got to wear respirators. Basically, have to be covered because during the chrome plating process, it's going to give off some kind of carcinogen.
Right. Yeah, and it's an electrolytic process, is it not?
Yes.
Right. Okay. One other question. You spoke about eyewash fixtures, and oftentimes some lab users and some safety officers have strong preferences regarding the style of eyewash fixtures that works for their institution. Do you have a recommendation or a preference when you deal with clients on the style of eyewash fixture that's most appropriate?
Well, yeah, I'm seeing a general trend in the marketplace that, customers, as far as environmental health and safety individuals, when they're looking at their standards across their campus, they're getting away from handheld eyewashes. Of what they're doing is they're preferring putting the application in the product where you have a paddle with a swing down eyewash over the sink. I'm seeing that becoming more and more predominant in the marketplace.
Mm-hmm. So in some cases, like a pivot style.
Right, exactly.
Okay. I had a question. You spoke about flammable gas nozzles and things like that. I have to admit that that's something that I don't necessarily get involved in specifying, but what materials are currently being recommended specifically at the nozzle heads for flammable gases? What does Broen Lab typically produce?
Well, as far as the nozzles are concerned, we always use red brass, and they cannot be removed. They're fixed.
Okay, so
either you on burning gases, either it's a fixed red brass nozzle, or you can also specify swedge lock fittings or quick connects that also have an automatic shut-off valve within the fixture itself. So I see all three applications: fixed nozzle, swedge lock, and quick connects.
Okay, excellent. One last question I had was related to the way that architects and engineers can specify these components so that they're appropriate for use. For instance, can consultants consult directly with manufacturers like Broen in a design assist mode to ensure that the specifications are working appropriately for the project?
That happens every day.
Okay, that's what I...
Doesn't necessarily have to be Brown Lab. It could be the XYZ company.
Mhm.
But that's what that's part of our responsibility, designing safe environments.
Exactly. I think that I appreciate that. That's often a take-home message for that. I want to make sure that other architects and engineers hear about is that there's assistance out there for people who are maybe doing a lab and haven't done labs routinely, or just getting involved in new specialty applications that the specialization is out there. And we can't always be Renaissance men and women that know it all instinctively. That we do have to consult with the marketplace to make sure that we're meeting international and regulatory standards, right?
Right, exactly, because there's so many specialty applications out there right now as far as laboratory fixtures, emergency showers. You really have to understand what's happening in the laboratory, or if it's non-burning gas, or burning gas, DI, or water. I mean, there's so many different special applications, especially when you get into instrument grade gases. You could, if you're not careful what you're doing, you're really going to have an improper installation. You have to understand what's going on, make the proper recommendations.
Excellent. Thank you for that. Martin, were there any other questions from the group?
Yeah, there are a couple other questions here. It starts with a comment that you made the statement about the water temp for emergency showers between 70 degrees and 90 degrees Fahrenheit, depending on what the requirements are. The question is what sets the requirements?
Well, it's going to be the local EH&S personnel set the standards for the campus. That's why you have an adjustable thermostat on it, because they'll tell you what it should be set at. I've seen applications where they set it at 75 Fahrenheit, and some applications where they set it at 90. That's going to be at the high end. So it's going to be local jurisdictions.
Okay, so it's a local issue. Okay,
it's a local issue.
Yeah. So now, depending on what the requirements are, oh no, that's the question I just read. I apologize. If someone can also, just trying to read this here, I'm having some difficulty with my screen. If someone can. Is it possible to say how long in feet or meters is 10 seconds from the accident to a shower? Do you have any experience regarding that?
Yeah. It's 10 seconds. It all depends on where, like if you're in front of a fume hood, all right, you're probably going to, if there's a potential accident there might be, escapement of gases or something, boiling water or whatever it might be. But typically you're going to locate it next to a door, which is probably a good 20 feet.
Okay, 20 feet.
And I wouldn't say any greater than 20 feet from a potential accident-prone area.
I'm just trying to read. There's another question here. What has been your experience regarding the installation of floor drains in the vicinity of emergency showers, and if they are needed or not?
Well, again, that's a local issue because a lot of places don't put floor drains in an emergency shower, which means that you're going to have a big mess. But in a lot of places, especially healthcare facilities, they don't put floor drains in there because they're worried about bacteria buildup.
Yeah, it makes sense with the heat and everything, and
right.
Wouldn't get used only sporadically.
It's Kevin here. That's a favorite topic of mine from working on lab projects. It becomes a discussion point on every project, and we often take the tact and the approach that a lot of facilities do that. There's an operation and maintenance requirement for floor drains as well, and they have to maintain them as being primed with water. So oftentimes a lot of facilities will opt not to, because the instance of an emergency, they would just deal with a localized cleanup in the event that they did have to discharge the emergency shower. And the other issue that comes with floor drains is sloping to floor drains, which often causes problems for cart traffic in labs, where, you know, if you do have a floor drain there and you have a slope to drain, it can cause big problems with large volumes of sample movement in labs and things like that. But that said, you know, it becomes I think, correct me if I'm wrong, Rick, but it does become an institutional preference.
Correct. You know, at every single campus I work on, they've got, you know, again, it's the discussion, floor drains and no floor drains, but I see a market trending to no floor drains in these new facilities.
Right.
Okay, well, we have no further questions. If there's nothing else from anyone, I guess we'll let Rick sign off here. And Rick, on behalf of SLCan, we sure appreciate you taking some time and presenting to us today. So thank you very much.
Well, you know, I guess I'm going to see everybody in Winnipeg, so I'll be there in October.
Great. We'll look forward to it.
All right. Thanks so much, gentlemen.
Okay, thank you.
All right.
Bye now.
Thank you.